Now we will do problem based on the all chapters. As all the topics discussed in this chapter that are working rule of integration, sum rules of integration, definite integral, limit as a sum, substitution rule, integration by part. On this basis we are going to solve some problem. So problem number 1 is find the value of minus 1 to 1 sine cube x cos raised to power 4x dx. So let I is equal to minus 1 to 1 sine cube x cos raised to power 4x dx. Let f of x is equal to sine cube x cos raised to power 4x. So f of minus x is equal to sine cube minus x into cos raised to power 4 minus x. So we get as sine of minus theta is minus sine theta and power is odd, so it becomes minus sine cube x, and cos of minus theta is cos theta, so it becomes cos raised to power 4x, that is minus f of x. So by definition of odd function, f of x is an odd function. Therefore, by using the theorem 3.5, we have minus a to a f of x dx is equal to 0. So by using theorem 3.5, so value of minus 1 to 1 sine cube x cos raised to power 4x dx is equal to 0. So this is the theorem number 1 which is on the basis of theorem 3. This is the problem number 1 which is on the basis of theorem 3.5. Now the second problem is, that is number 2. Evaluate I 0 to 1 x square 1 minus x raised to power half dx. So here we will replace x by 1 minus x, that is a minus x. We get I is equal to 0 to 1 minus x whole square 1 minus x whole raised to power half dx. So we get I is equal to 0 to 1 minus x square become a square plus b square minus 2x, and in the bracket we get 1 minus 1 plus x raised to power half dx. So if we see, by using the that property, replacing x by a minus x, problem become very easy. We get this bracket into x raised to power half dx, that is multiplying x raised to power half by whole the bracket. We get 1 into x raised to power half, x raised to power half into x square into x raised to power half is x raised to power 5 by 2 minus 2 into x raised to power 3 by 2 dx. So if we see, we have to use a simple rule, that is the rule of power. So we get here x of 1 by 2 plus 1, that is 3 by 2 over 3 by 2 plus x raised to power 7 by 2 over 7 by 2 minus 2 times x raised to power 3 by 5 by 2 over 5 by 2. Range is 0 to 1. So we get here 2 by 3 outside, that is 1 raised to power 3 by 2 is 1 minus 0 plus 2 by 7 is out. 1 raised to 7 by 2 is 1 minus 0 minus 2 times 2 by 5, again 1 minus 0. So we get I is equal to 2 by 3 plus 2 by 7 minus 4 by 5. That is LCM is 105, and we get here 70 plus 30 minus 84. So as a whole we get 16 over 105. So value of integral, that is 0 to 1 x square 1 minus x raised to power half dx is equal to 16 over 105. So you see here, by replacing or by using the property changing a to a minus x, we get the required result. Now the next problem is, that is problem number 3. Prove that 0 to pi by 2 x over sin x plus cos x dx is equal to pi over 2 under root 2 log of under root 2 plus 1. Now the solution is, we have taken left hand side, that is let I is equal to 0 to pi by 2 x over sin x plus cos x dx, that is number 1. So by using the property replacing x by a minus x, that is 0 to pi by 2, it becomes pi by 2 minus x over sin of pi by 2 minus x plus cos pi by 2 minus x. So we get here 0 to pi by 2, pi by 2 minus x dx, sin pi by 2 minus x is cos x and cos pi by 2 minus x is sin x. Give its name as number 2 and in the starting it is number 1. So on adding 1 and 2, we get 2i is equal to 0 to pi by 2, pi by 2 dx over cos x plus sin x. That is, we get I is equal to pi over 4, 0 to pi by 2 dx over cos x plus sin x. So there is another way to solve such type of problem, that is, do not replace cos and sin by tan function. There is another method to get the result, that is, we have sin x plus cos x in the denominator. So we use the form, if we have a cos x plus b sin x, we will multiply and divide by a square plus b square. It becomes a over under root a square plus b square cos x plus b over under root a square plus b square sin x. Then replace a over a square under root a square plus b square as we want to make the form. If we want to make the form cos formula, we will replace it by cos, and we make the form of sin formula, we will replace it by sin. So it is our wish. So here we have replaced this by cos alpha. It is cos x and b over under root a square plus b square by sin alpha to convert the formula in the form of cos. So we get here cos of x minus alpha, that is cos a minus b, where alpha is equal to tan inverse b over a. So by using this form, we get I is equal to pi over 4 integral. So we are multiplying and divide in the denominator by root 2, because here a is 1 and b is 1 and under root a square plus b square is 2. So we will divide and multiply by root 2 in the denominator. So we get here pi by 4 root 2, 1 over, limit is 0 to pi by 2, dx over cos x minus alpha. where alpha is tan inverse b over a, that is tan inverse 1, that is pi by 4. Therefore, I is pi over 4 root 2, 0 to pi by 2 dx over cos x minus pi by 4. Therefore, we get I is equal to pi over 4 root 2, 0 to pi by 2. It becomes 1 over cos is secant x minus pi by 4 dx. So what is the integration of secant x minus pi by 4? That is log of secant x plus tan x over the range 0 to pi by 2. So we get I is equal to pi over 4 root 2 log of secant pi by 2 minus pi by 4 plus tan pi by 2 minus pi by 4 minus log of secant minus pi by 4 plus tan of minus pi by 4 by substituting 0 and pi by 2, that is f of p minus f of a, by using the fundamental rule of integration. So we get I is equal to pi over 4 root 2 log of secant pi by 4 plus tan pi by 4 minus secant of minus theta is secant theta and tan of minus theta is minus tan theta. So we get pi over 4 root 2 log of under root 2 plus 1 minus log of under root 2 minus 1. So we get pi over 4 root 2 log of under root 2 plus 1 over under root 2 minus 1. Therefore, I is equal to pi over 4 root 2 log of under root 2 plus 1 under root 2 minus 1. Now rationalize it. Under root 2 plus 1 under root 2 plus 1, dividing and multiplying by under root 2 plus 1. So we get pi over 4 root 2 log of under root 2 plus 1 whole square over a square minus b square. So we get pi over 4 root 2 log of under root 2 plus 1 whole square over a square minus b square. So we get pi over 4 root 2 log of under root 2 plus 1 whole square, that is equal to right hand side.